All right, let's look for the answer to number five. We're going to look for the volume of the solid whose base is bounded by the curves y equals x squared minus 3 and y equals x with the indicated cross sections, which is squares, taking perpendicular to the x-axis. All right, so we have to know what this looks like first. Now, some of you who can graph this well will know that this will basically be two graphs, one a diagonal graph y equals x and a parabola just going like this roughly from here to here. Now if you don't know that, what you want to do is just quickly graph it on a graphing calculator, punch those two equations in. Oh, I did it for you already. Okay, so there it is. Now with calculators you can immediately find the points of intersection, and if you don't know how to do that, make sure you look it up on YouTube somewhere, how to use your TI calculator or whatever it is that you're going to use to find the points of intersection, because you need to know where they intersect to write up your integral. Okay, so we know that it intersects from -1 to 3. We're just looking at the x coordinates here. And we want to draw a square prism on this graph, like a three-dimensional figure, as if we're putting it on the ground. So it's going to look something like this, maybe here and maybe like somewhere here. So I'm going to use the red outline to represent the bottom of this three-dimensional figure. So it's going to look something like this, okay? And that's the bottom, and the rest that kind of protrudes out of the ground, will look like, okay, will look like that. Okay, so this is literally standing on this. Okay, so this red piece right here represents this bottom part of this prism. Okay, and we want to find the volume of this, and on an infinite scale, make it so thin that we can find the area or the volume all the way up here. So you'll basically see, you have to kind of imagine these square prisms sticking out of the ground, where this is drawn on the ground. That's the shape of the base on the ground. Okay, so as I told you before, you're basically looking for the volume of that. And it's really, really simple. And by the way, to understand how to find the volume of this, it's not, I mean, we know our typical length times width times height. Yes, you can use that, but it's better to look at it in this manner. Put this face down on the ground so that it'll look like, let's see, so it'll look like this. Okay, let's just use the same color. And I'm gonna put the red right here to represent that I've basically just toppled this down so that it's facing sideways. And the reason for this is because this is considered to be my actual base, okay? A prism whose base is on the top and there's one on the bottom. This right here is my height, okay? So if you put it this way, it's obvious that that's your height, but if you stand it up in this manner, it doesn't look like the height. But this height right here corresponds to this distance right over here, and that's really, really important. Usually the prompt will tell you how to designate this width right here. So this width is called dx because it's perpendicular to the x-axis. Okay, if it's perpendicular to the y-axis, you'll use dy. So instead of saying the word width or height, we're going to use the symbol dx or dy. Now, to find the volume of a normal prism sitting there, it's the same for all prisms. It's capital B times H, or capital B represents the area of the base. The area of the base we're going to find, but now we know our height, we're going to represent the height as d what? dx. And that's very important because that's going to help us to understand how to write up our equation. Our final equation has to have the letters x inside here. Now, our next step is just to figure out how to designate the area of this base, which happens to be, now look at this picture again. The area of the base is basically this square piece right here. We want to find the area of that. It tells us that it's a square, and that's really important because whatever value we have, whatever side length we have, it'll just be s times s. Okay, so base, the area of the base of this green square is s times s, or s squared. So now the question is this: how do I figure out what the length of this side is on this square pyramid? I mean, this square prism. Well, as I told you, this right here represents this red line right over here. So the real question is, how do you find this part, okay, or that part? How do you designate that in terms of its, I guess in our perspective, it looks like the height, but we're going to call it S. So let me write it in like this. This right here is my letter S, okay? Well, this length is the difference between the y value here, which we'll call y2, the upper y value, minus the lower one, the lower y value, which we call y1. So S is equal to, or the length is found by taking the upper y value y2 and subtracting the lower y value y1. Well, what is the upper graph look like? It's y equals x, so now we have a designation. This is y2, so let's replace that with the letter x. And y1 is our parabola, so we'll call that x squared minus x minus 3. So if you simplify this, this would be x equals x minus x squared plus x plus 3, and negative x squared plus 2x plus 3 is the side of my square. Okay, so here I'll put s is equal to negative x squared plus 2x plus 3, and this is going to be exactly the same. So the area of the base is taking those two sides, s, or we'll replace it with this whole equation, and we're going to square it. So our equation for the area of the base is s squared, which is negative x squared plus 2x plus 3 squared. So this is my base. And that now will be placed into that, that parentheses. Negative x squared plus 2x plus 3 squared. Now don't forget the squared because it's area, okay? It's all of that squared. Okay, so we're done. All we need to do now is draw up an integral sign, put everything we need in there, like that, and just figure out from where to where we want to cut up these thinly sliced square prisms. Well, as I told you before, it's perpendicular to the x-axis, so it's going to be placed like this. Well, in this case, right around here. And as you move to the right, it'll get bigger, 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 and then smaller and smaller, smaller. So it's going to move from -1 to 3. So these are the numbers we want to plug in. And by the way, again, this gives it away. We want x value, so these two has to be x coordinates. Okay, now you can do it by hand, but it's going to take a long time because you have to square this whole thing out. The best thing to do is plug it into your calculator, okay, and punch it in, and you'll have your decimal answer. Okay, so I'm going to hit menu, calculus option number 4, and lower bound is -1, upper bound is 3, and the equation is parenthesis negative x squared plus 2x plus 3, raise that to the second power. Oops, I'm doing this all wrong. Delete, delete, delete. Okay, so squared, there we go. And let's get rid of that unnecessary parentheses. Okay, and I'm just gonna double check everything before I enter. Yep, enter, and I got 34.13 with the bar. Okay, let's check the answer key, and it says 34.133333, and yes, this is the exact answer on the answer key. All right, I hope that helps.